My name is Brittany Anderton. I'm a graduate student here at the University of California, San Francisco, and I'm in the lab of Dr. Andre Goga. So I am focused on studying aspects of liver cancer. I'm interested in asking how liver cancer cells use nutrients differently. In the past decade or so, there's been this whole resurgence of this field known as cancer metabolism, asking how cancer cells use nutrients differently than normal cells and how they use them to their advantage to proliferate and make lots of new cells, which is essentially what the disease cancer is. So I'm working to find ways to better understand how these cancer cells have altered or different nutrient metabolism and ways that we may target that therapeutically. So I'm originally from northwestern Pennsylvania. I'm from a very rural community. I also happen to be first generation to college as well to graduate school. So that means that neither of my parents went to a four-year college. My father is a factory worker. He works for Channel Lock Tools. And my mother is an RN, so she does have an associate's, although she didn't go to a typical four-year school and she doesn't have a bachelor's. So growing up, I didn't know much about different types of science careers. So when it came time to go to college, I knew that I wanted to study biology, but I wasn't exactly sure what I wanted to do with it. And I kind of thought that based on the careers that I was familiar with as a child, I thought maybe I would want to be a veterinarian or a dentist. And I didn't know at the time that people spent their entire days asking questions and doing experiments. And I feel that as soon as I figured that out in college, that was the career that I wanted to pursue. And so pretty quickly I decided to apply to grad school at the end of college and pursue a career in research. We have a history of cancer in my family. My grandfather died of lung cancer when I was very young, and also my aunt died of breast cancer when I was in high school. So it was a disease that hit very close to home, and I wanted to contribute to better understanding of it and perhaps leading to future therapies for cancer. I find it highly energizing. I think it's fascinating. It's actually a very fundamental question. You can imagine that cancer is a disease of uncontrolled growth and proliferation, and we know that growth requires nutrients and building blocks and macromolecules for making new cells. So the field of cancer metabolism is actually very fundamental. How can we starve cancer cells so that they just don't have these building blocks anymore and can't make more cells? I feel like I often work in waves in labs. So some days I will be doing, or some weeks even, I'll be doing lots of one particular thing, and then that will kind of phase out, and then I'll be working on a different aspect of my project and a different question, and I'll be working on that for quite some time as well. So currently a typical day for me is doing a lot of molecular biology. I'm working with DNA and I'm working at the bench, and I'm trying to make new DNA structures where I can express different genes in cells. And so this requires a lot of reactions where we are cleaving DNA and ligating different pieces of DNA together. And to a layperson, it looks like I'm working with a lot of clear liquids in small volumes and doesn't really look like I'm doing much. But hopefully the output of it will be that when I put these DNA molecules into cells, they will cause different expression in the cells that I put them into, and will change the phenotype of these liver cancer cells, and hopefully that will lead to some better understanding of how these liver cancer cells work. Actually, the field of cancer is moving in such a way that many people are trying to find combinatorial therapies. So that means that combining multiple ways to inhibit multiple different pathways, and that means in the future perhaps my corner of the field and the research that I'm doing could contribute to along with somebody else's research, to a combination therapy for liver cancer. I would like to see greater diversity in scientific research. I feel that we have a lot of really bright minds in research, and I don't feel that there is any shortage of people being interested in science research. However, I feel that we could increase our diversity as far as people from different backgrounds and increasing women in science, of course. Additionally, I would like to see at the end of graduate school, so for example, I'm finishing up my PhD and I'll be looking for a job in the next year or two. I would like to see more options for PhD holding scientists at the end of graduate school versus maybe the typical tenure track where you go to graduate school and you do a project and then eventually you become a professor. I don't believe that that is the only option for us. I think that getting a PhD and being a scientist teaches you a lot of really valuable skills. And even if you don't decide to stay at the bench, there are many careers out there, but I would like to see those options presented earlier on so that people can be making earlier decisions about where they want to go at the end of graduate school.